Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams. We are now at question 9 of this CXC CSET June 2013 General Paper 2 exam video solution. And in part A of question 9, we are told that a girl wishes to buy X oranges and Y mangoes to carry in her bag, and that there are a number of limitations and constraints that are applied. Now note that we want to buy X oranges, and so X is the number of oranges, and Y mangoes, and so Y is the number of mangoes. So this is a linear programming question where we are presented with the limitations and constraints that would govern the number of oranges and the number of mangoes that she can buy, and we have to write those limitations and constraints as linear inequalities, and then we have to show those linear inequalities on a graph so we can identify the region on the graph that would satisfy those limitations and constraints. So let's proceed by looking at the constraints, and we will write the inequality for each constraint. So the first constraint is that there is space in her bag for only 6 fruits. Now the word fruits here is taken to mean the oranges and the mangoes together. So basically what it means is that her bag can take only 6 fruits, and so the total of the oranges and mangoes together would have to be less than or equal to 6. Her bag can take no more than 6. Bag has space for only 6 fruits, and so the total number of oranges and mangoes in the bag will have to be either 6 or less. And so the inequality to represent that constraint would be this: X plus Y would have to be less than or equal to 6. That is, the number of oranges plus the number of mangoes in the bag would have to be 6 or less. That is, less than or equal to 6. So that's the first inequality for the first constraint. Now secondly, we are told that she must buy at least 2 mangoes in order to get a good deal. At least 2 mangoes here means 2 or more mangoes. She must buy 2 or more mangoes. And so the number of mangoes, which is Y, has to be greater than or equal to 2. And so the inequality representing this constraint is Y greater than or equal to 2. The number of mangoes, which is Y, must be 2 or more, greater than or equal to 2. And that's the inequality for the second constraint. The third constraint is given in the form of this inequality. And this inequality is saying that Y is less than or equal to 2x. Now remember that Y is the number of mangoes, Y mangoes, so Y is the number of mangoes, and X is the number of oranges. So this inequality is basically saying that the number of mangoes has to be less than or equal to twice the number of oranges. And so we are required here to write the meaning for this inequality, and that is it. The number of mangoes must be less than or equal to twice the number of oranges, because remember, Y is the number of mangoes and X is the number of oranges. And so we can write that meaning. The number of mangoes must be less than or equal to twice the number of oranges. That is what this inequality means, and that's the answer for part 3. Let's move down now to part 4. So what we have so far are these 3 inequalities, and part 4 wants us to draw the lines associated with these 3 inequalities, and we can go ahead and show how those lines will be drawn to represent these 3 inequalities. Now firstly, the associated lines will have to be drawn unbroken, because in each case the equal is a part of the inequality. This first inequality is X plus Y less than or equal to 6, so the equal is a part of this inequality, and so the line would have to be drawn unbroken. In this case, Y is greater than or equal to 2. Again, the equal is included, and so the line for this inequality would have to be drawn unbroken, and in this case y is less than or equal to 2x. The equal is included again, and so the line associated with this inequality would also have to be drawn unbroken. And so the lines for the three inequalities each would have to be drawn unbroken. The line is drawn unbroken to indicate that the equal mark is a part of the inequality, and so the line is a part of the inequalities, and that is simply because the equal is a part of the inequality in each case. And then now these are the lines that would have to be drawn. This below here means that we want the region below the line. So the equal means that we want the line, and so we draw the line unbroken, but the less than means that we want below the line. And the less than means below because the y on the left hand side of this inequality is positive, and when the y on this side of the inequality is positive, less than means that we want below the line, and the line that is associated with this inequality is the line x plus y equals 6. And so for this inequality we are going to draw an unbroken line, and we will want the region that is below this line. The line will be a part of inequality, hence it is drawn unbroken, and then we will also want the region below the line to account for the less than sign here. In this case, the line that we'll draw is the line y equals 2. Again, it will be drawn unbroken to account for the equal mark here in the inequality, and then we would want the region that is above the line because we have a greater than sign here. The greater than sign here means above the line because the y on this side of inequality again is positive, and so the greater than means we want above the line, and equal means that we also want the line y equals 2 to be a part of the inequality, and so again that line will be drawn unbroken. For the third inequality, y less than or equal to 2x, the line associated with this inequality is the line y equals 2x, and again because the y on this side of the inequality is positive and we have a less than sign here, it means that we also want below the line. So the equal mark here again means that we want the line itself to be a part of the inequality, hence the line is drawn unbroken, and the less than sign here means that we want below the line. So we're going to draw this line y equals 2x, and we are going to want the region that is below the line. And so these are the three lines we are going to draw, and these are the sides of the line that we want. Below this line, above this line, below this line, and the three lines will be drawn unbroken to account for the equal sign that is a part of each of the inequalities. So let's go proceed by drawing this first line. Now this line x plus y equals 6 is a easy line to draw. It will cross the y-axis at 6 and also cross the x-axis at 6, because on the y-axis when x is 0 the y value will be 6, and on the x-axis when y is 0 the x value will be 6. And so x plus y equals 6 crosses the y-axis at 6 and also crosses the x-axis at 6. This is a x plus y line, one of the easier lines to draw. So these are the 2 points on this line that the line will pass through, and that is our line x plus y equals 6. And we have to remember to label the line with the equal sign because the line represents the equal mark, and then this arrow here pointing down means that we want below the line. So the region we want so far is somewhere under the line here, below the line. For the second line, y equals 2, that's a horizontal line passing through 2. Lines of the form y equals a number are horizontal lines, and so y equals 2 is a horizontal line passing through 2 because all points on that line will have a y value of 2, and so the line y equals 2 is this line. Y equals 2 is a horizontal line passing through 2. And again, we have to label the line with the equal sign because the line represents the equal mark. It is drawn unbroken because the line will be a part of the inequality, and then this arrow pointing upwards means that we want the region above the line. And so far the region that would satisfy the inequality is somewhere inside here, below this line and above this line. But to complete the process, we now have to draw this third line, y equals 2x. Now y equals 2x will pass through the origin because when x is 0, y is 0, and so 0, 0 is a point on this line. And also we can choose another point. For example, when x is 3, y will be equal to 2 times 3, which is 6, and so the point 3, 6 is also a point on the line. This line y equals 2x will pass through 0, 0 here, and also will pass through the point 3, 6 right here. And so we can draw the straight line through those 2 points and label the line again with the equal sign. The line again is drawn unbroken to account for the equal sign that's in the inequality, because the line is a part of the inequality. And then this arrow pointing down means that we want the region below this line. That's what we want, below this line. And so the region we want is this triangle inside here. It is below this line, and above this line. And so those are the three lines associated with the three inequalities. And so we can move to part 5, which is now asking us to shade the region representing the solution set for the three inequalities. And the solution set for the three inequalities will be represented by this triangle inside here, because this triangle would satisfy all three inequalities. It would be below this line, and above this line. And the three lines are drawn unbroken, meaning that the lines also are a part of the inequality. And so that is the region we would shade. And that is it. We have shaded the required region. So that's the answer for part A of question 9. And let's go down now to part B. Now part B is asking us to write this quadratic expression in this form. So basically what we are required to do is complete the square. Here we have the perfect square, and that's a standard question for the CXC C6 syllabus. Now there are several methods of completing the square of a quadratic expression, but the method I like to use is one that involves using the coefficients of the standard form to form the vertex or turning point form. This is the vertex or turning point form with the perfect square, and we will have to complete the square to go from this standard form to this vertex or turning point form. Now the xt here and the yt here are constants, and the xt and the yt can be derived from the constants in the standard form, and the t here and here are simply taken to mean the turning point, and therefore xt is the x value at the turning point on this quadratic function, and yt is the y value at the turning point on the quadratic function. So xt, yt would be the coordinates at the turning point. Now xt can be calculated using this formula, negative b divided by 2a, where a is the coefficient of the x squared term in the standard form here, and b is the coefficient of x. And the yt can be calculated using this formula, 4ac minus b squared divided by 4a. A again is the coefficient of x squared, b is the coefficient of x, and c is a constant term in the standard form. And so the xt that goes here can be calculated using this formula, and the yt that goes here can be calculated using this formula. I must point out also a significant difference between this form here and the form that we're asked to write it in. Notice there's a plus here while there's a minus here. And so if you're going to use this formula, we must have x minus xt. And the value that we get from this calculation of xt would go here, and the negative sign must be placed here. And so now we can proceed to calculate the value of xt and the value of yt. But let's identify the a, the b, and the c from this standard form. A, as I said, is a coefficient of x squared, and so in this case a is equal to 3. B is a coefficient of x, and we must carry the sign of the coefficient of x, and that's negative 12, and so b is negative 12. And then c is a constant term. C is a constant term, and that is equal to 8. So all we need to do is substitute a and b here to calculate xt, the xt value that would go right here. So it's minus b, and so it is minus a negative 12 because b is negative 12, and then we are dividing by 2 times a. So therefore we divide by 2 times 3 because a is 3. And this calculation works down to 2 because negative here would give us a positive 12, and 2 times 3 is 6, and so 12 divided by 6 is equal to 2, and so xt is equal to 2. So we'll replace this xt here with 2 in this vertex form. For yt, it is 4ac minus b squared all divided by 4a, and again we are substituting these values a, b, and c, and so this becomes 4 times 3 because a is 3 times c, which is 8, minus, that's this minus here, remember we're not squaring this minus, but b, no, b is negative 12, so we're squaring negative 12. So it's negative 12 all squared. So when we square this term, it will become positive 144. But this minus sign is not squared, so it will remain as a negative. And when we calculate this, the result is negative 4.
and so yt is negative 4. And therefore we have the value for a is 3, so this value a 3 would come here. We have xt is 2, and so this xt here we replace it with 2, and then we have yt equals negative 4, and so this plus yt will become negative 4, and therefore we can write that vertex form. The result is y equals 3 into x minus 2 all squared minus 4. A from here, as I said, is 3. X minus, that's x minus xt here is 2, so 2 goes here, square outside the bracket, and then plus yt is negative 4, and so plus yt replace negative 4, and that's it. We have completed the square and we have written it in this form. And so all we can do now is compare this expression with this expression, so we can write the value for a, h, and k if that was required. So if we're comparing this with this, we see that a is equal to 3, plus h is equal to negative 2, and plus k is equal to negative 4. And so we can write that a is equal to 3 plus h is equal to negative 2. So where we have plus h here, we have negative 2, and so h is equal to negative 2, and then plus k is equal to negative 4, and so k is equal to negative 4. And that's the answer for that part. We have written this standard form in this vertex form using this method xt, yt. Xt is the x value at the turning point, yt is the y value at the turning point, and so we have the coordinates of the turning point of this quadratic function. Let's move down now to part 2. So what we have so far is that y is equal to 3x squared minus 12x plus 8. That's a standard form for this quadratic function, and we completed the square into this form. This is the vertex form or the turning point form, and from this form we can identify the coordinates of the turning point. Xt, which is the x value at the turning point, is 2, that's a value here, and yt, which is a y value at the turning point, is negative 4. That's the yt value right here. That's negative 4. And now we're asked to sketch the graph of this quadratic function, and on our graph we are to show the y-axis intercept and the minimum point. Now the y-axis intercept is the point where this quadratic function crosses the y-axis, and at that point on the y-axis x will be 0, and so at x equals 0, this would be 0 and this would be 0, and so y would be equal to 8, and therefore the y-axis intercept is the point 0c, because remember that the c value in this standard form is 8, and so the y-axis intercept we can get from the standard form. It is always the point 0c, because as I said, on the y-axis when x is 0, these two values will be 0, and so y will be equal to the c value, in this case is 8, and so the y-axis intercept is the point 0.8, and then the minimum point is the turning point on the quadratic function. In this case, because the a is positive, we have a smile shape quadratic function, and when we have a smile shape quadratic function, the turning point is a minimum point. So in this case, the minimum point is xt, yt, and the coordinates of the turning point are what we calculated here, 2, negative 4, and so the coordinates of the turning point are 2, negative 4. And so we can do our sketch, and we'll do our sketch on this graph. First we'll show the 2 points that we're asked to show. That's the y-axis intercept 0.8 right here, 0.8, and our turning point is 2, negative 4, 2, negative 4. And as I said, because the a in this quadratic function is positive, the graph will have a smile shape. So the graph will pass through this point, come down to this point here, turn, and then go back up such that it has a smile shape. So the graph will shape like this, crosses the y-axis at 8 and then turns at 2, negative 4. So this point is our y-axis intercept, that's it, and this point is our minimum turning point. And as I said, the graph will come through this point, turn here. It is a smile shaped quadratic function, and that is it. And that's a sketch of our function. Y equals 3x squared minus 12x plus 8. That's a sketch of our graph. Crosses the y-axis at this point, 0.8, and turns a minimum turning point, 2, negative 4. So that's the answer for this part of the question, and that's the end of question 9. And we'll do our next question, question 10, in the next video. See you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 CAPE Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.